We are about to work through all the problems in example 5. So we're going to work through all the compound interest problems first, and then we'll move on and work through all the future value of an annuity problems. I just want to take one more chance before we do that to go over these formulas again. Okay, so I am on page 5 of the sections 3.2 and 3.3 notes. Okay, again, at the top of the page is the compound interest formula. A equals P times 1 plus R over M to the MT power. Okay, again, you're going to use this when you're saving money. Okay, and it is a one-time deposit. And then as far as what the variables stand for, okay, A is the account balance, P is the original deposit, R is the interest rate in decimal form, M is the number of compoundings per year, and we'll talk more about that in just a minute, and T is the time, has to be in years that the money is invested. Okay, so again, usually you're going to see this in the context of saving money through a one-time deposit, but remember a couple of the examples in example 5, we looked at an inflation problem. So you may, if you encounter an inflation problem where you have an item and you're looking how it, its value has changed over time, like I gave you the gasoline example where, years ago gas used to be very, very cheap. You could buy it for just a few cents per gallon, and now it's, $2 or more. So you're looking at how the value of a quantity has changed over time. That's an inflation problem. You're going to use compound interest for inflation. We also said that you could have a compound interest loan. Okay, so if you have a compound interest loan, R would still be the interest rate, T would be the amount of time that the money's borrowed, M would still be the number of compoundings per year, but then P would be the amount of money borrowed, and then A would be the total amount that you'd have to pay back when you paid back the loan. Okay. As far as the future value of an annuity formula, okay, it has the same variables. It's more complicated, okay, just at a glance of it. And that is because, remember, now you're making regular deposits. Okay, so the formula accounts for that. Okay, still going to use this in the context of saving money. Okay, so for this formula, you will only be using it to save money, and you have to be making regular deposits. Okay, so the variables mean the same thing. R is the interest rate as a decimal, M is the number of compoundings per year, T is the time that the money is invested in years. P is going to be the amount of the periodic deposit. Okay, so it's no longer a one lump sum, but whatever that periodic deposit is, whether you're making it monthly or weekly or whatever, P is the amount of each deposit. Okay, A is going to be the account balance. Okay, so before we do the practice, let's take a minute to talk about the M value. Okay, so M is going to appear in every formula pretty much going forward. It's not something that appeared in simple interest, but it will be in almost every single remaining formula in this chapter. M is the number of compoundings per year, so the number of times that the interest is added to the account per year. So let me write that on here. M is the number of times the interest is added to the account per year. Okay, so with both of these formulas, and even when we get to the other formulas that we haven't talked about, like the present value of an annuity, present value of an annuity and amortization, you're still going to see this M value pop up. Okay, so you have to know how to handle it. You're going to have, in all of these problems, okay, you're going to have phrases like compounded monthly, compounded daily, compounded annually, and so on. Okay, so that phrase hints at what your value of M should be. Okay, so if something is annual, it happens one time a year, so your M value would be 1. Okay, if something is semi-annually, it's every 6 months or twice a year. So if you're compounding semi-annually, you would be adding the interest to the account 2 times a year, okay? Quarterly, 4 times a year. There's 4 quarters in a year, okay? Monthly, M would be 12 because there's 12 months in a year. Weekly, there are 52 weeks in a year. Daily, we are typically going to use 365 for M unless we're dealing with simple interest, and then we're going to use 360. So remember, you will be told what to use. It will be clear whether you're using 360 or 365 in a daily case, okay? So these are your M values. So if you ever get stuck, refer back to this, okay? And again, the value of M in your formula that you use, it's going to come from that phrase, compounded whatever, and then you pick it from here, okay? All right, lastly on this page before we start our examples, okay? It's a little note about solving for time, okay? If you look at these two formulas, okay, and the formulas for present value of an annuity and for amortization are just as complex, and occasionally you might have to solve for time, okay? You're going to want to know how long it's going to take you to save a certain amount of money or how long it's going to take you to pay off your student debt. That's important. It's a good thing to know. How long is this going to take me? And the problem with these complicated formulas is that time appears in the exponent, okay? And so to do that, okay, you're going to have to use logarithms. If you haven't seen them before, I will walk you through it, so don't worry about that. But this note at the bottom, okay, is going to give you a little heads up about what happens when we solve these particular equations for time, okay? So thinking back to the compound interest formula and the future value of an annuity formula, those formulas, if you want to determine the time in years it will take to accumulate A dollars by depositing P dollars at annual interest rate R compounded M times per year, all we need to do is solve the compound interest, well, we need to solve the compound interest formula for time, okay? Same thing if you were making regular deposits and you needed to solve the future value of an annuity formula. If you're looking for how long it's going to take, you're going to have to solve for time, okay? But here is the big thing, this particular bullet, okay? When we are going to solve these guys for time, because time is in the exponent, we're not going to go all the way through and solve for t. We're actually going to stop and find M times t. So if the compounding is monthly, we are going to stop when we find 12t, the number of months. Or if it's quarterly, we're going to stop when we find 4t, which would be referring to the number of quarters. If it's weekly, we're going to stop when we find 52t. So you're actually solving for 52t, not t. And that would represent the number of weeks, and so on. And then once you have solved for MT, you'll punch in all the numbers, and that's going to give you some nasty decimal. You're going to take that decimal and round up to the next whole number. Always. Even if your decimal was like 0.4, and you know that if a 4 comes after, you're going to keep it the same. No, you're still going to round up, okay? You're going to round up to the next whole number. And we do this every time we're solving for time, with the exception of simple interest. We round up to the next whole number of periods to make sure enough time passes to accumulate the amount of money we're trying to accumulate, okay? So what you need to remember, it'll make more sense when we do an actual example, okay? Instead of solving for t, you're going to solve for M times t, okay? This applies to all the formulas where the t is in the exponent. You're going to solve for M times t. And then you'll be able to punch in the right side, get some nasty decimal out of your calculator. You're going to take that decimal and round it up to the next whole number. You're rounding up always just to ensure that enough time passes to accumulate the amount of money that you're trying to get. Okay, so now we will proceed with the examples for compound interest from example 5.